Alright, Geometry Kids, this is Mr. Kim. Again, you guys were in my class for just a few minutes, so this is the instruction video for today's lesson. Listen carefully because there's some parts I'm going to have you skip and there's parts that I'm going to have you do. I'm going to guide you through some things and then you're also going to do some things on your own. Okay, so 924, you're pretty much doing all the classwork problems, but again, within each sub-problem, or each problem, the sub-problems, you might be not doing some of them. So let's just read the introduction. What more can I construct? Other constructions. So this is where we're taking everything that you've learned about creating angles, recreating angles, creating bisectors or perpendicular bisectors, creating arcs, things like that, and you're going to put it together. So far you've developed a basic library of constructions that can help create many of the geometric shapes and relationships that you've studied from chapters 1 through 8. For example, you can construct a rhombus. We've done that. We've done isosceles triangle. We've done right triangles, specifically two types. We've constructed a regular hexagon, and we've also constructed an equilateral triangle. So as you continue, keep in mind the following focus questions. What geometric principles or properties can I use? Why does it work? Is there another way? So this says team challenge here. Obviously, you're not you doing it as a team. Let me summarize this. There's a neat trick. Pretty much in every triangle, there's a point called the centroid. That is the balance point. In other words, it is the point that's the center of the shape. Now, when I say center, I don't literally mean the center. It's just the center of balance, because it is where the medians of the triangles meet. Medians are basically lines from the vertex that intersect the middle of each side. Okay, I'm going to say that again. Lines from the vertex that intersect each side. So we're going to read the math notes box at the bottom of the lesson pretty much. So there it is. So there's a picture of the centroid. Right, so if you see the diagram here, this is the centroid. That's the center of balance. That's kind of where, if you were to put your finger there and kind of hold up a triangle, it would stay balanced. In other words, the center of balance. If you notice, this segment drawn from here goes from the vertex and it touches or cuts through the middle or the median of the midpoint of a side, and then oppositely this vertex, you see this segment, the midpoint of an opposite side, and same thing here, midpoint. Now these are not angle bisectors. In other words, the medians do not necessarily cut the angles in half. Alright? If it does, it's a coincidence. Like, for example, in an isosceles triangle, the median, right, would bisect one opposite side, right, if it's an isosceles triangle, but not necessarily the other two. So it's a coincidence if it does. So you assume that they are not congruent angles here when you draw a median, right? So these two are not necessarily congruent. But what does become congruent because of the midpoint are the sides. They get cut into two. Cut into two, cut into two. So what you have to do is draw these, and that's what we're going to do in our very first problem. So obviously I can't use a compass on my iPad. It's very, very hard to do. So I'm going to have to just wing it, and you guys are just going to have to wing it with me, right? So you have a compass, right? You have paper, you can pause the video, but I don't have, obviously, a lot of the tools. So you're going to have to hear me and kind of watch me and make it happen. All right, so we read about medians right here in part A. And we're going to draw a large triangle. You draw your own, so it's just practice. Work together to carefully construct the three medians and locate the centroid. And this is the part we're not going to do. You guys aren't going to glue to cardboard and see if it works out. Trust me, it works. But we're not going to do that. So I'm going to extend the page here. Please draw a triangle as best as you can. Try to make it scalene, in other words, unbalanced, right? Not equal. Use a straight edge. And pick any measurement you want and make it acute. In other words, don't make it obtuse. That's going to be much harder. So I'm gonna use a tool and kind of draw hopefully what is a scalene triangle. That looks pretty scalene to me. Alright, and I'm gonna use a different color here, probably blue. Let's just test if it's blue. Alright, and what I'm gonna attempt to do is to draw the medians. Now if you remember back in the picture, right, I'm going to draw a mini triangle here. We need the midpoints, right? We need the midpoints. And from the vertex to the midpoint, that's going to be the median. From the vertex to the midpoint, that's going to be the median. And pretty much where they meet, where they meet. And now some of you can eyeball and say, oh, there's the centroid. But what we want to do is use a compass to do that. Okay, so we're going to try and mimic this to find the median. If you remember back to our constructions, right? If we drew a perpendicular bisector, that would pretty much find the median, right? Because it's not only lines are perpendicular, but it's a bisector as well. So we don't need the right angle part, we just need the bisecting part. So we're going to construct arcs above and below each pair of vertices, and then that'll pretty much give us our midpoints, and then from the midpoints we can then connect a segment to the vertex, or to each opposite vertex. So imagine then this is what I would do. Now I'm totally winging this. So there's a arc above, below, there's arcs above, and then I would then draw this line. Now I'm totally guesstimating here, so this is not how you really do it. I'm assuming this is the midpoint because again I can't use a compass on my iPad. So I'm eyeballing it right now. These look about bisected. I'm not going to write the right angle sign here. I'm not going to do this because I don't need that. What I do need though is the midpoint. So I'm just going to draw a midpoint here. Okay. Then I'm going to do the same thing over here. From this vertex to this vertex, I'm going to draw some arcs above, below. You use a compass, please. And again, I am simply eyeballing it. There's no way that this is accurate at all. Again, this is the downfall of technology, obviously. Because of it, I can tell you all this, but because of it, I can't actually use a compass. And in any case, that's where my midpoint would be. So you can obviously tell I'm fudging it a little bit, but that's what I have to do. Again, we don't need the right angle symbol. And then same thing over here between these two vertices. I'm going to create arcs above and below. Please keep your radius the same of the compass. So again, completely eyeballing it. If I ever see this on a test or your mega quiz, you know I'm obviously going to mark it wrong. So please don't say, oh, Mr. Kim, you found a shortcut. And no, I did not. This is just what I have to do. Alright, that's about it. Alright, so there it is. So I've got 3 midpoints. Okay, so assuming that these are midpoints, hopefully yours are accurate. Now I can connect them to the opposite vertex, and then if I use a straight line tool I can do that, and hopefully they're going to meet, and once they meet, that is called the centroid. So let's see how this works out, shall we? I'm going to use a different color. Let's use orange. Let's see how this works out. No way. Hey, it worked out all right. Okay, so I know that's a little inaccurate, but that's because I can't actually get to that point. If you ever used software, you know sometimes it'll move or jump a space or something. Those of you who know what I'm talking about, hopefully you understand. In any case, there's my centroid. Whoa, that's a line. Let me erase that. There's my centroid. Go ahead and label it. And that's it. So that's the center of balance. If I were to cut this out and put my finger right on that point, it would stay in balance. Each vertex here, 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 here would not outweigh the other, and it would balance technically. Alright, so that's done. That's part A and B. Remember, we're not doing C. Please do this on your own. Make sure you do it. If you need to practice, just do it again. Build another triangle. And again, use the idea of a perpendicular bisector, but we just need the bisecting part, not the perpendicular part. This is going to go away if you need to redo it. 3, 2, 1, rewind. Here we go. That's just my computer making noise. Alright. Let's get out of here. Go to the next problem. In the next problem, 100, this is where you use your resource page. On the packet that we gave you earlier this week, there's 2 triangles. Looks like this. That's not it. Okay, the reason why there's 2 is not because, well, technically we were supposed to cut these out, but I decided to give you 2 because if you mess up on one, royally mess up, you've got another one, okay, below. So use one. If you need more practice, use the other, or if you just mess up, use the other one. Let's just read this and we'll get going. In the previous problem, you constructed a centroid, which is special because it's a center of balance of a triangle. However, there are other important points in a triangle. For example, visualize a point inside ABC, right in here. Below that is the same from each vertex. In other words, is there a point here that's equidistant from the vertex, from each vertex. Okay, I'm going to tell you what the name is in a sec after we do it. But it says on the resource page, use a compass and a straight edge. Find a line that represents all the points that are equidistant, the same distance from points A and B, and then justify. So we're going to build that. Joanna asks, how can we find one point? And then Joanna asks, how can we find one point that is the same distance from C2? So now this one just says same distance from A and B. Joanna says, hey, we're going to do the same thing and try to find the same distance from C. So that's part B. Question C, Joanna points out that the intersection of the perpendicular bisectors of the sides of the triangle is equidistant from the vertices. I'm going to explain this. That means there's a circle that passes through all three vertices, she noted. Use your compass to draw the circle. So we're going to do all of this in one problem. Okay, you answer them separately, but I'm just going to do them. Okay, so the question was, remember this, that we're going to find a point somewhere here that's equidistant from all the vertices. So it's the same distance here, here. So look, for example, it'd be 3 units this way, 3 units this way, and 3 units this way. That's what we're trying to find. Okay. So let's get into the actual this, and I'm going to explain how to do it. This time we're going to do the same thing we did for the centroid, but we're actually going to use the perpendicular bisectors this time. Okay, so we're going to rely on the perpendicular bisectors. We're not going to rely on the medians this time. So kids get confused because what we previously drew was a centroid. Now what we're going to draw is a thing called a circumcenter. I'm going to say that again, a circumcenter. So it's like circumference, circum, and then center. Okay, actually I should probably just write that down. So circumcenter. You get all these wonderful ideas when you're teaching something, you know? Anyway, here we go. So same thing between A and B. I'm going to find the perpendicular bisector, and this time I'm relying on it, so make it a good perpendicular bisector. You want it to cut through the triangle, so make it a big perpendicular bisector. So go above and below, use arcs above and below, and make it long. Okay, so here we go. Again, I'm fudging this. I'm not doing it correctly at all. I'm assuming a lot right now. Okay, and so I would have like arcs above here and below here, and from points A and from points B, and then I would draw. Actually, let's use a straight line tool, kind of make it more believable. Makes me feel like I'm actually doing it accurately. So something like that. Okay, we're going to draw the perpendicular sign now, so go ahead and do that. We're going to do the same thing for AC and BC. Okay, so I'm just going to work. Hopefully you're working too. Again, not accurate by any means. Oops. Above, below. Okay. I'm hoping this works out. I have a feeling it might not. Oops. All right. And then lastly, from A to C, these two right here. And draw. Well, it kind of worked out. Okay. So what this is now is the circumcenter. And question A and B basically dealt with these three, right? Oh, I forgot the perpendicular signs. Okay, assuming they're perpendicular. Notice that I'm not drawing a median, so a point from here to here, or from B to where it intersects. I'm not doing that. What I am going to do though is draw a point from A, C, and B to the circumcenter. So let's go ahead and put a dot here. I'm going to use a different color now. Let's use red. And there's a line. There's a line. No, that's way off. there's a line. So you can kind of tell, but they are somewhat equidistant. So these are all equal. Obviously, we did perpendicular bisectors, so these are equal as well, right? And this is why kids get confused between a circumcenter and a centroid. Okay? But we only needed perpendicular bisectors so that we can see where the perpendicular bisectors meet. From the point where the perpendicular bisectors meet, that is the circumcenter. Okay? And then from the circumcenter, these are equidistant points away from the vertices. So this point to C, this point to B, this point to A. If you have a compass now, you can pretty much measure the radius from here. Oops, whoa, totally. You can measure the radius from here to here, and from here to here, and they should be roughly the same. And the same thing from here to here. Because they're all the same, question C says, hey, we can draw a circle. So that's correct. You can draw a circle around this triangle, okay, and it should pretty much hit C, A, and B. So I'm going to attempt to do that. Please don't laugh, but I'm going to cheat a little bit, okay, again, because I can. I need to find a color. Yeah, let's use that. Here we go. Let's see if this works. I have no idea. Alright, I'm going to have to do this several times. I think that's about it. Yeah, kinda, sorta, yeah. I think so. It's the best I can. Alright, so my iPad cut out. I don't know at what point it cut out. If all of a sudden we see, actually, I think I know when it cut out. This is called a circumcenter, right? And it's kind of equidistant all the way around, kind of, right? I couldn't really use a compass, but you get the idea. So this is a circumcenter. So if you don't like what you did, scroll down, or not scroll down, go down to the second one and try it again. If you want to repeat and watch this again, go ahead. But we're going to move on in 3, 2, 1. So lastly, you have a couple more problems left. This is going to be more about the centroid, and you're going to kind of prove why it works the way it does. So I'm going to leave this to you to work out. Okay, it's just some math you have to do. And then 102, you guys are going to do the following. So what other specific triangles can you construct? So you're going to construct 3. Choose at least 3 of the different triangles, and I'm going to let you just choose 3, but I'm going to tell you which to do. Okay, so you're going to, for classwork, right, you're going to construct them, and you're going to write some directions for them, kind of like how I gave you directions. I'm going to make you write directions. So I want you to do the following. An isosceles triangle with side length AB given at right. So these would be the two sides that are isosceles. I want you to construct a triangle with sides, no, take that back. I want you to construct an isosceles right triangle with leg length PQ, okay, isosceles right triangle. And I want you to construct a triangle with side lengths 3, 4, and 5 units, okay. Again, you get to choose what the units are. Remember, kind of in our 30, 60 right, 90 right triangle, we said we get to define what 1 is. So I would first define what 1 is, and then you can then define what 3, 4, 5 is, if you get the hint. So you're doing the first one, the second one, and the fifth one. All right. So that's what you're doing for classwork. You're writing down directions for them, so that I want you guys to actually compare on Tuesday when I see you again. All right. So that's it. Good luck and have a good weekend. We'll see you later.